Okay, so let's get some more practice here finding the derivative. We're going to use the function f of x equals x squared to find the slope of the tangent line at 1 and at -2. Let's go ahead and start off with 1. We have f prime of 1. So in the x spot, we have a 1. So we have the limit as h goes to 0 of, we have f of 1 plus h minus f of 1 all divided by h. Okay, so we need to plug in some values into the x within our function. Let's see what that looks like. Alrighty, we've plugged in our values and we have this algebraic expression that we need to deal with. And we have the limit as h goes to 0 of, we have 1 plus h squared. That literally means 1 plus 2h plus h squared, and then minus 1 to the power 2, which is just 1. So let's see what we can do at this point. We have a 1 and a minus 1, which we can get rid of. And now we have a left, we have a 2 plus h, 2h plus h squared, all over h. So I'm going to do a couple steps at once. I'm going to factor out an h from the numerator here. So we have h times 2 plus h, and this is all over h. So I got rid of the 1s and I factored out an h, and we see now at this point here we can cross off these two h's. And so what we're left with at this point is the limit as h goes to 0 of 2 plus h. And there's nothing we can do here to simplify except plug in h equals 0, and we see that the slope of our tangent line right at 1 is equal to 2. What the heck does that mean? Let's get a visual of what's going on here. What I need to do is graph f of x equals x squared. So I'm going to go ahead and graph this. Okay, so here we want to understand what f prime of 1 really means, what f prime of 1 equal to really means. And so we go to our function, f of x equals x squared, and we go to that point 1. We go to 1, and we know the slope tells us to go up 2 and then over 1. Now, we could also go down 2 and over 1 to come up with another point that's on that line. So the slope of our tangent line that just grazes our point right at 1 is equal to 2. That means the rate of change right there at 1 is equal to a 2. We can see here that as the x values increase, the rate of change gets steeper and steeper and steeper. The line becomes more and more steep there. Now the previous problem, it said also to find the equation of the tangent line right at 1. Well, what that means is we're looking for y equals mx plus b. So what is the equation of our tangent line? Well, we know that the slope of the tangent line is 2. What is the b value? We could just eyeball it right now and say, oh, yeah, well, that's equal to a -1. But if we wanted to know exactly how to find it algebraically, we would need to plug in an xy point and solve for b. What is an xy point that's on our line? Well, right here. When x is 1, we plug that in, we have 1 power 1, which is equal to a 1. So we plug in that point when x is 1, y is 1. And we solve for b. And that gives us a b value of -1. And so we end up with y equals 2x minus 1 for the equation of our tangent line.